This is Mark with your Advanced Assembly Technology Minute.
My name is Joe Grand. I sometimes say I'm a engineer by day and hardware hacker by night. But really, I just grew up kind of hacking on electronics and building electronic projects. I'm an engineer by lifestyle. Embedded security and sort of hardware hacking, it's a really, really hard problem. And it's something that we're going to face, and it's not going to go away. Like, you can never be 100% secure. And that's something also that we have to think about as engineers is like, let's just think, how would an adversary attack our system? And then try to make those sections as secure as we can, given the current state of the art, but knowing that somebody might have an attack for it, or somebody might come up with an attack for it later. So it's definitely like engineers are on the losing side of this cat and mouse game, because the hackers are always going to have an advantage because they have no constraints. They can go after the system in however they want. We're engineers, we design by constraint. We have to get the system working. We're defined by certain parameters of the chip and how it functions, but hackers just go outside of those parameters to break systems. So it's really just, at this point, we just want to try to make things as easy as possible, as secure as we can, but still make them manufacturable and testable and things that we actually have to deal with as engineers in the real world, but get rid of what I call the low-hanging fruit of like all this easy entry points that hackers can use. Some of the most common kind of entry points for embedded system hacking I see are test points for the first thing, unpopulated connectors. And when we see test points and we see connectors, especially if they're unpopulated connectors on the board, as hackers, we look at those and say, great, those are probably going to be on interesting signals that we should look at. But from an engineering perspective, we need those things in there so the manufacturers can easily connect up to the board to program it. So it's this trade-off of really security versus convenience. Convenience wins in a lot of situations because convenience means manufacturing is going to be cheaper, it's going to be easier, but then the risk being that these low-hanging fruit features end up being on boards that we could exploit. There are a lot of advanced techniques that I'm starting to see. So things like differential power analysis, where you can monitor power consumption of a system and look for minute changes in power to extract, say, bits of an encryption key during an encryption operation, which is like crazy mind-blowing. But it used to mostly be something that you'd see in academic journals and a few people doing demonstrations of it. But now there's actually tools available to the public that make that attack easier. So engineers can do these power analysis attacks against their own devices and see, are they susceptible? And really, most designs are going to be susceptible to advanced attacks unless countermeasures are intentionally built in. But it's a great tool to test for that. Other types of advanced attacks would be like fault injection, also known as glitching, where you're forcing a chip to operate in some environment outside of its specification. Usually that's going to be power related or timing related, where if you have control of the clock line, you take the oscillator off the board and you inject your own clock, you have your clock at a normal speed and you operate it outside of where the chip is designed to operate. So, maybe you're running at 20 megahertz and then you go up to 100 megahertz for a few clock cycles. If you do that at the right time, that can skip over critical instructions, that can cause the system to do something weird. And, the chips are only defined within certain parameters. And we're trusting the vendor that it's going to work within those parameters. So when an attacker comes and tries something outside of that, we as the engineers, we can't really predict what somebody's going to do. So it's funny because as an engineer, I have like this very rigid kind of mindset as I go about designing something and as I go about hacking something, even though the hacker world, you hear about think outside the box and think differently and all this stuff. But even when I'm hacking a product, I go through this list of things, almost unintentionally. So the first thing I do is what I call information gathering. And that's taking the product, even if I don't have the product yet, but my target product, I go online, I try to find every possible piece of information I can about it, looking at forums and the website and things designed not for end users, but for administrators or maintenance personnel or sales material, everything I can, marketing material, because a lot of that stuff, you can get little pieces of information from just public documentation that you could use as a starting point to break a system. I'll do product teardown, so I'll figure out how to open up the product, get access to the circuitry. From there, I'll do component identification, look for the major parts on the board, get information about those, do some preliminary reverse engineering to see how things connect, and say, okay, these are microcontroller, microprocessor, memory, external peripherals, these are the things I want to start attacking. Then I'll look for interfaces, inter-chip communication interfaces, how are chips talking, external interfaces, so UART interfaces, debug interfaces, stuff like that. And then basically make a list of all the things that I want to try to attack on the system. And it's going to depend on my goal of attacking the system in the first place. If I'm just trying to extract information or memory, that's going to be different than if I wanted to use that as a way to say, escalate my privilege to give me more control of the device that then I can pivot to something else on the network. That's all going to vary. But going through that process and then try to extract memory contents and then do advanced techniques if I need to. But it's sort of like peeling layers of an onion. So you start at a high level and just go layer by layer, and you just look for the easiest way in. And if it happens to be everything is locked down and you have to do a complex attack, you do. But generally, you don't have to, and you start with something easier, and that's all it takes, because the hacker is just looking for that one weak link.
If you liked this video, let us know by clicking the like button at the bottom of the screen. But don't stop watching now. We have other educational and informative videos on this channel. To learn more about what Advanced Assembly offers and how we can help you, please visit aapcb.com.